Hi guys, this is the second installment of section 2.2, naming compounds. We're going to learn how to name binary and ternary ionic compounds. So let's start off with the definition of a binary ionic compound. The word binary means two, and so we're looking at a compound that's going to contain two elements. An ionic compound contains a metal and a nonmetal. And the metal and the nonmetal are going to be held together by ionic bonds. Remember that metals form cations, which are positively charged, and nonmetals form anions, which are negatively charged, and the positive and negative attraction is very strong and holds the two ions very close together, thus forming an ionic bond. Remember, you can determine what kind of element you are looking at by using a periodic table. Any element to the left of the staircase line is a metal, and any element to the right is a nonmetal. I do want to point out at this time that hydrogen is on the wrong side of the table. It really is a nonmetal. So how do you identify and name a binary ionic compound? Well, we're going to look for two elements, and we're going to look for a type 1 metal and a nonmetal. A type 1 metal will be any metal that is found in groups 1A, 2A, or 3A. To name these compounds, you're going to write the name of the type 1 metal, which is the cation, and then you're going to write the name of the nonmetal, which is the anion, with the suffix "ide." The subscripts in the formula do not matter when naming this type of compound. So with our first example, you can see that it is a binary ionic compound. It is made of two elements, a metal and a nonmetal. So we will simply name the metal, which is sodium, and name the nonmetal, which is chlorine. We will drop the ending and we will add "ide," thus we get sodium chloride. Example 2 is also a binary ionic compound. We're going to go ahead and cut this in half. We know that calcium is the metal and bromine is the nonmetal. So Ca will get its regular element name, and Br, which is bromine, we'll drop the ending. It's the "ide," will become bromide. We do not worry about the subscripts in this type of compound, so the answer is calcium bromide. Example 3 is also a binary ionic compound. We're going to cut that in half. This is your metal, and this is your nonmetal. So we will give K its regular element name, and we will take O, which is oxygen, drop the ending, and add "ide," potassium oxide. So this is your self-check. Go ahead and write the name for the following compounds, and then turn to the next slide to see the answers. So in this section, all of the examples are binary ionic compounds. So I'm going to go ahead and just draw a line through each one of them, cutting them in half. And because each first element is a metal, and each second element is a nonmetal, I'm going to follow the rules we just worked with. The metal gets the regular element name, and the nonmetal ends in "ide." So the first one is lithium oxide, the next one is strontium phosphide, the third one is magnesium sulfide, and the fourth one is barium iodide. Ternary ionic compounds are compounds that contain at least one polyatomic ion. A polyatomic ion is an ion that has more than one atom covalently bonded together with a single charge. Polyatomic ions are mostly anions, and they will be found in the latter half of an ionic compound most of the time, as seen in the first drawing. Occasionally, the polyatomic ion will be found in the front half, where we will be looking at the ammonium ion. It will be acting as a cation, and sometimes we'll see the polyatomic ion in both the cation and the anion position. Alright, so you might be a little scared when looking at this table. There are more polyatomic ions on this chart than you will ever need to know, and you don't need to memorize them. You will be given a reference sheet in class that you can use at all times to either get the name of the polyatomic ion or the chemical formula. If we take a look at chromate, you'll notice that it is composed of 1 chromium and 4 oxygen. Those are collectively bonded together, actually covalently bonded together, and they have a single charge. Most of the polyatomic ions end in the suffix "ate" or "ite," and then there are a few that will actually end in "ide." Hydroxide is one of them, and cyanide is the other. And then, of course, there is one positive polyatomic ion that you will be using, and that is called ammonium. So there are some hints to identifying polyatomic ions. The ammonium ion is the only positive polyatomic ion, and it will sit in the front half, so that's an easy way to recognize it. All other polyatomic ions will be in the back half of the compound. They're the anions. The subscripts within the polyatomic ion are important because they must match exactly with the ones on your ion list so that you can decipher the name. And if there are parentheses in a chemical formula, the polyatomic ion will be inside. You do want to ignore the numbers on the outside. Okay, so we're going to get some practice identifying polyatomic ions. Make sure you have your reference sheet in front of you. We're going to underline and name the polyatomic ion in each compound. Remember, we're looking for parentheses. Inside the parentheses will be the polyatomic ion. We're looking for the ammonium ion, which will only be found in the front. And then for the other ones, a good way of identifying a polyatomic ion would be to look for two capital letters. So in this first example, you can see that there are two capital letters right next to each other. If I go to my reference sheet, you will notice that NO3 is called nitrate. In the second example, I can recognize that NH4, which is the positive polyatomic ion of ammonium. In the third example, I see a parentheses. I'm going to look up OH, and that is hydroxide. In the fourth example, there is the ammonium ion again, but then you will also see that there are two capital letters after that. So this is one that has two polyatomic ions, and that is phosphate. And then the last example, the two capital letters are sitting next to each other in the back half, and that is carbonate. So how do you identify and name ternary ionic compounds? We're going to look for more than two capital letters next to one another, or the parentheses, or the NH4 ion, and we're also going to be looking for at least one metal and one nonmetal. To name these compounds, we'll write the name of the cation. That will either be the metal, in which we will use the element name, or the ammonium ion, in which we will use the word ammonium. If the anion is a polyatomic ion, we will write the given polyatomic ion's name, as seen on the reference sheet. If the anion is a single nonmetal element, we will write its name with the suffix "ide." So example 4 is a ternary ionic compound. I see the parentheses, so I know that I have a polyatomic ion. So I'm going to go ahead and just cut that in front of the polyatomic ion. I know that I have a metal and a polyatomic ion set of nonmetals. So I'm going to name Ca with its regular element name, and I'm going to look on my reference sheet and come up with a name for NO3, which is nitrate, and thus I get calcium nitrate. Remember that the outside subscript does not matter when we are naming the compound. This is also a ternary ionic compound. I'm going to identify the polyatomic ion. This time I see two capital letters, so I'm going to go ahead and just draw a line. In front of that polyatomic ion, I see a metal, and I see a polyatomic ion. So Na is going to get its regular element name, which is sodium, and PO4 is going to get its polyatomic ion name, seen on the reference sheet, of phosphate, and we get sodium phosphate as our answer. Another example of a ternary ionic compound. I'm going to draw my line separating the polyatomic ion from the metal. K will get its regular element name, which is potassium. CO3 will get its special name, seen on the reference sheet, as carbonate, and potassium carbonate is the answer. It's time for your self-check. You're going to write the name for the following compounds. Flip to the next slide to see the answers. So in your first example, you see a parentheses. You know that's going to house the polyatomic ion. The regular element name for the metal is calcium, and the special name for the polyatomic ion is acetate. Once again, I'm going to draw a line separating the metal from the polyatomic ion. Li has the name of lithium, and SO3 on your reference sheet is sulfite. Once again, I see a parentheses. Inside that will be my polyatomic ion. So I have a metal again. Its name is barium, and OH is hydroxide. And in this last example, you will see that there's a parentheses, and in that parentheses is the only positive polyatomic ion. So we're going to actually draw our line there. We're going to give it its special name from the reference sheet, which is ammonium. And you'll notice that there's a single nonmetal. Single nonmetals always end in "ide." So remember your transition metals. They're found in group B on the periodic table. They're your type 2 metal. They have the possibility of having more than one cation charge. In the middle of this screen, you can see some of the common transition metals and their charges. And then I need you to remember that silver, cadmium, and zinc, which are also in group B, only have one charge. Silver is +1, cadmium is +2, and zinc is +2. We talked about how these charges need to be memorized. And then the last thing I want to point out to you is that tin and lead are actually group A elements, but they act like the transition elements. They're pseudo transition elements. They will have more than one charge, and you do need to memorize those as well. Now, one of the ways that you can do that is that both tin and lead are found in group 4 of the group A elements. So that would help you come up with a +4 charge, and then you just need to remember that it also has a +2 charge as well. So how do we identify and name ionic compounds with transition metals? Well, we want to look for that type 2 metal, that transition metal that is found in group B in the middle of the periodic table. To name these compounds, we're going to write the name of the type 2 metal. We're going to write the name of the anion. Remember that that element name will end in "ide," or if it's a polyatomic ion, it will have a special name. And then to determine the charge of that transition metal, we're going to have to do a little math. We're going to find out the total negative charge, which will be equal to the total positive charge in all neutral compounds. We'll divide the total positive charge by the number of metal atoms in the chemical formula. And then once we determine the charge, we'll write it as a Roman numeral in parentheses after the type 2 metal's name. So in example 7, I have a binary ionic compound. I'm going to go ahead and draw a line to cut it in half. I know that this is my metal and this is my nonmetal. What I want you to also know is that this is a type 2 metal. It is a transition metal. So we will name Cu with its regular element name, which is copper, and the single nonmetal, which is chlorine, will become chloride. So we need to come up with a charge for copper. In order to do that, we're going to come up with the charge for the anion. For chlorine, it's -1, as seen on the periodic table. The total positive charge must equal the total negative charge in a neutral ionic compound. Since there is only one chlorine, it will have a charge of -1, and so that means that copper's charge must be +1 in order to neutralize it. And so that's why you see that there is a Roman numeral 1 behind the word copper. So our answer is copper 1 chloride. Example 8 is a ternary ionic compound as referenced by the parentheses. I'm going to draw a line in front of that, and I will notice that the first half is a metal and the second half is the polyatomic ion. I will also notice that the metal is a transition metal. It is found in group B in the middle of the periodic table. So Fe will get its regular element name of iron, and the polyatomic ion of CO3 will get its special name of carbonate. We need to determine the charge of iron. It can be +2 or +3. So we are going to go to the negative ion. We're going to go to the reference sheet. We're going to look up its charge, which is -2. We know that there are 3 of them. So 3 times -2 is -6. Now we said that the total positive charge must equal the total negative charge. They must add up to 0. So I know that this has to be a +6. but there are 2 iron. So I'm going to divide that number by 2, and that's actually going to give me the charge of iron as plus 3. So you can see that there is a Roman numeral 3 between the words iron and carbonate. Thus your answer is iron 3 carbonate. Example 9 is an example of a binary ionic compound. I'm going to cut it in half. I have a metal and a nonmetal. And once again, if I look on the periodic table, I will notice that this is a transition metal. So Zn will get its regular element name of zinc, and Br will end in ide, so the bromine turns into bromide. So we need to determine the charge for zinc. If I go to my periodic table, I will notice that bromine has a charge of -1, and there are 2 of them, giving me a negative charge of -2. I know that the positive charge and the negative charge, when added together, have to equal 0, so zinc has to be +2, and since there's only one of them, that is going to be its charge. However, remember that zinc, cadmium, and silver, which are transition metals, do not have more than one charge, so there is no need to put the Roman numeral 2 in the name. The name is simply zinc bromide. Now it's time for you to do a self-check. I want you to write the name for the following compounds, and then you can check your answers on the next slide. The first example is a binary ionic compound. I'm going to cut it in half. I've got a metal and a nonmetal. The metal's name is lead, and the nonmetal is chlorine. We're going to drop the ending and add ide. Because lead is a transition metal, we do need to figure out its charge. So we're going to go to the periodic table. We're going to grab the charge of the negative ion, which is chlorine. That's a -2. So this lead has to be a +2 in order for these to equal 0. Since there's only one of them, this will be lead 2 chloride. In the next example, we have the same 2 elements. This time, the ratio is not 1 to 2, but 1 to 4. So I'm still going to come up with a charge of chlorine, which is -1. There are 4 of them, which gives us a -4 charge, and only 1 lead needed to maintain that neutrality, so that has to be +4, and thus this is lead 4 chloride. In the third example, I have a binary ionic compound. If I cut that in half, I've got my metal and my nonmetal. Mn is called manganese, and O for oxygen will turn into oxide. Manganese is a transition metal, so I will have to determine its charge. In order to do this, I'm going to find the charge of the anion, which is -2. There is only one of them, so its charge is -2, and that means that manganese's charge must be +2 in order for these to equal out to 0. Thus, the name of the compound is manganese 2 oxide. And the fourth example is also manganese oxide. -2 is the charge for oxygen. That's going to give me a net charge of -6. In order for this to equal 0, manganese would have to have a total charge of +6. Notice that there are 2 of them. I'm going to divide that by 2, and that will give me manganese as a +3 ion. And so in its name, I'm going to put in that Roman numeral 3 behind manganese. So this concludes how to name both binary and ternary ionic compounds. We'll have plenty of practice in class, and I will see you there.